Hey guys, I have a little experiment that I want you guys to find out what exactly I'm doing. So what I have right here is a 2-liter bottle full with water. And then I have a little magic thing right here that I want you to find out what I am doing to make it sink and then float back up again. So the first thing that I'm going to try is I have this little magnet on a pen. You see it? So what I'm going to do is I'm going to line it up with this right here. You see it sinking? I'm going to have it go back up. So what do you think is going on? This magnet is able to pull this down and then pull it back up. What happens if you think I'll take the magnet off? Do you think it'll float back up or sink? It comes back up. So what I'm going to try to do, this is the magic part, I'm going to rub my thumb on this magnet and see if it comes off on my thumb and does the same exact thing. Okay, and then it comes back up. So this thumb works. Do you think this one does? It has not touched anything. Okay, no, it's just this thumb that's touched the magnet. Alright, so the next thing that I have to see if it's going to work is I have my phone, which is being charged. So I'm going to put my phone, line it up, and have it sink and come back up. And then sink, come back up. So, if I take the charge out, do you think it'll still do the same thing? It doesn't have the energy coming from the wall anymore. It doesn't. So let's plug it back in and see if it does the same thing. Does anyone have any idea of what is actually going on? What if I tell you that my phone was not plugged into anything? What else would be causing this to sink? Alright, well let me try and break this down for you. So what I'm actually doing is pushing into the thing and it starts to sink. And I let go and it comes back up. So, what is happening is when there's more stuff that is closely packed together than the stuff that it's actually in, on average, makes things sink. So when I'm saying stuff, I'm pretty much saying molecules. So, does that mean that heavy things sink and light things float? Well, if you think about it, what does a boat do? A boat floats on top of the water. But then, if you put a penny in the water, it'll sink. So, a boat weighs tons and tons, but a penny is so small, yet they do two completely different things. So, how it works is, even though density is what we're talking about here right now. So how much stuff is in how much space is what density is pretty much about. It's pretty much the measurement of how packed it is. So a boat is less packed with molecules than a penny is. So if you have two things that weigh the same exact amount, for example, yourself, when you're in a pool and you're just floating there on top, you're more likely to sink. But if you take a big breath, you have more air, but that weight doesn't change anything. You weigh the same exact amount, but now you're more likely to float. So, what is happening is something like this. So, when you're on top of the water, this is how you look. Not technically, but kind of. So, you see all the little dots are on here. But this dot is the same amount of dots that are in here, but there's more space. So even though they are the same weight, they have different densities, which causes them to either sink or float. So this one, what do you think would happen? This one would sink because it's more densely packed together, and this one is more likely to float. So that is why when we have this right here, it is floating because it's less dense, especially at the top. But when I'm squeezing it together, it sinks because I'm making it more densely packed. I'm causing less area on the outside and more in the inside, causing this little thing to sink. What I have right here is the Cardassian diver experiment. So what we have is a pipette full with water, not all the way, it's only halfway to the top, and a little nut to keep the weight, so it does sink whenever I put it in. There you go, that's all.